we show, so we will have more sea level rise than this without question, just maybe not that soon. The only question is how soon it happens. So now I just want to talk about the question I started with was, when there's a specific, everything I've shown you so far is sort of general trends. What can we say about the patterns of extreme events and how they're related to climate? And that's already harder. So if you think about what climate means an average, right? The difference between climate weather is, people say, like, if you don't like the weather, wait till tomorrow, but if you don't like the climate, move, right? The climate is the average, and averages are nicer to deal with statistically than individual events. So trends in extreme weather events, there's not that many extreme events, so you're counting fewer events, your statistics aren't as good, so all the science becomes more uncertain. When you're talking about a single event, right, the reporter calls me and says, was this snowstorm due to climate change? That's even harder, because you don't have no statistics, you have one event, right? So what can you say about that? And this was some examples that when there was a big snowstorm a couple of years ago, these are actual headlines I cut out of articles that, that came out at that time. When reporters would ask this question, we used to say, well, climate change is about the averages, but we can't say anything about individual events. And actually, we don't say that anymore. The science has advanced to the point where, in some cases, we can make statements about the relationship of climate change to individual events. You can never say climate change caused this event. It's just never, because every event has many causes. Most of them are natural. The weather's just fluctuating. If an extreme event happened, it's always the case that some random confluence of events of the atmosphere just happened to go right to make something unusual happen. That's why they're extreme. But global warming just pushes the probabilities a little bit in one direction. So at most it can be one cause among many, and usually a small one. But we can make quantitative statements like it made it such and such percentage more likely, or such and such percentage more extreme, and we now have the tools to do that. And although I hadn't been working on this in the past, I was asked to be on a committee for the National Academy that recently wrote a report on how well we can do this, because it's a rapidly evolving science and it's in the media more and more. So National Academy was asked to do a report on it. So I learned a bit about it, and so I can report to you on how this, on what the basic conclusions are, how well we can do it. So how do we do this? How do we say something about a single event and how it's related to climate? If life were simple, we would have a long historical record of how often some event happens, and we would count in the past how often it happened, and we would count how many times it happened recently, and if that number had increased a lot or decreased a lot, we would say there was some long-term change. Sometimes we can do this. For heat waves, we can do it. They're the easiest events where the data are the best, and we can see that the trends are quite clear. We can do this, but a lot of times we can't do it. The data aren't, for most types of events, the data are not enough. It's easy to see why for the really big events you can't do it, because by definition they're very rare. So you just don't have enough of them in the historical record. So for most of the event types we have to use models, computer models, the same kind that we use to predict weather and climate. So what we do, there's a few ways of doing it, but I'm going to give you the most easy to understand, although not the easiest to do version. Imagine you have a model. It's a model that predicts the weather very well if you run it in weather prediction mode, and for the event that just happened, the hurricane or the flood or whatever, it does a good job of simulating those kinds of events when they happen. So then you just run the model for a long time without interrupting it, let it simulate many, many, many years of weather, and count how often the event that you're interested in happens. So if it's a flood in South Carolina, how often does it flood that bad in South Carolina if you just let it generate its own climate for 1,000 years with today's greenhouse gases. Then you do a pre-industrial case, a world that might have been, a world without humans, where you take out the human greenhouse gas emissions, and you do it again for 1,000 years, and you count how many times South Carolina floods then. And the difference, if you have enough statistics to say that there's a significant difference, the difference is the human influence. And so you can say something about the difference then. You have to have a good enough model. You have to have enough signal from climate change. I mean, climate change has to actually do something. Maybe the two look the same, and then you can't say anything. There are some major recent events where this has been, where people have made some convincing statements. This is the Australian heat wave that I mentioned before. These are actually coupled climate models. They simulate the whole climate, the atmosphere, and the ocean. And these are showing historical trends in temperature, and this is what you would get without the CO2. And then these are what are called histograms. So this is for some temperature anomaly, where say 1 degree average from above average, this vertical tells you how often that's happening. And so this is the historical average of September temperature for Australia, and this is the current average. And this is the pre-industrial average, and this is the current average. And so these values in this Australian heat wave were up here, and so you basically never get them. I mean, they're just outside the pre-industrial climate here. So this is like a hurricane that's stronger than any. This is like a heat wave that basically had never happened before. Had never been this hot in Australia. So this is pretty strong evidence. And then, but the models say that. Sorry, I shouldn't say it has been this hot, but the models say you can see a strong trend of it happening much more often, and the models say it wouldn't happen without global warming. So both the models and the observations are in sync, and you can make strong statements. So that's a heat wave. Oops. This is a Syrian drought. So my colleagues actually, this is Seeger's work again. This is, again, the place where the climate models agree that there's already a drought signal emerging in the Middle East. So the claim is, and it's pretty well defended, that the Syrian war that's led to the humanitarian crisis ongoing there and all the migration that's causing problems for the whole world, that was in part caused by a famine. That was one of the causes. And the famine was in part due to a drought, and the drought was in part due to climate change. It's not saying climate change caused the war. Obviously, a lot of other bad things had to happen, and a lot of other people had to behave badly, but it's one of the factors. So that's a pretty scary story. So this is just an example to show that a lot depends, when you ask how much did it have to do with climate change, a lot depends how you ask the question. It can be simultaneously the case that a given event is